Well, let's try to find out the slopes, meaning of the slopes, and how it can be measured, etc. So to begin with, you can see here we have three triangles are drawn. You can see very here, yeah, number 1, 2, and 3. If you see this, definitely if I ask you which has more slope, definitely you will say it's as a green, okay, which has a bigger slope, bigger slope. Just at this point, I like to tell you that all the slopes are measured with respect to x-axis. If this is x-axis, this is y-axis. All the slopes are always measured to the x-axis, and the slope of x-axis always taken as 0. The slope of x-axis always taken as 0, where the slope of y-axis is infinite, or you can say symbol way not defined, so it's very very high. Okay, with this understanding, let's go ahead. Again, I put the question back to you. That is, there are three triangles here, or three slopes here. In simple word, three slopes here, 1, 2, and 3. Which is the highest? Definitely your answer will be this green one, which is the higher slope. And which is the lowest one? Definitely your answer will be this orange one, which has the less slope here, you can see. And of course, the pink one will be in middle. Okay. Now, what does it make difference? Suppose if I take this as a y-axis, let's say, for example, I use this red color wire as a y-axis, and the black wire as a this your y-axis. I'm trying to measure the distances between x and y. If you see, I just compare these two. Okay, if I compare these distances, you see the x distance is higher, the x I taken black, and you find that x is bigger while the y-axis is less. Okay, in this case, so that's makes a big difference. What else? If I try to take the x, I kept the x constant here, you can see same, and you see now the slope is changing, but if I take this y, it's becoming less than the earlier one. Okay, so x is higher, x is same as like earlier, but here is higher and the y is smaller. If I go again back, x is the same distance we have, but you see this y is very small compared to any, but that's make the slope very very small. So it is basically we are talking about x and y distances, or base and height, what makes a big difference. If you take this as your x-axis, or this is your x-axis, okay, and this is a y-axis, okay, and this is x distance, a y distance. Similarly, this will be your x, and this will be y, and this will be x. Then definitely your slope has to do something with, okay, something with y distance and x distance. That is the this height, and this is base distance, height and base distance. Okay, let's take a few more example before we try to find out how it can be find out. You can see here that two more slopes are here present here compared to earlier. If you see here, okay, if you see this distance and this distance, what do you observe? Okay, this here now x is very high, and the height of y same to as like a triangle 2, here two slopes, but this, okay, but so slope has reduced because of this bigger distance. So compared to this, the slope has reduced. Come here, you see we kept the same height as y, but again we increase the x distance, so slope again decrease. So in the both the cases you can see that slope has decreased drastically. That means all about is your slopes can be understood by means of your this height and this base. So also you see these angles are also changing here. This angle, you see this angle, this angle, okay, similarly you can define this angle or this angle. In all the cases, see the angle also differing. If the slope is high, the angle is higher. If slope is less, the angle is becoming less. So how do can understand this? Okay, let's try to put some point here. That means the angle also has to do something here. Can you say that? Okay, this all angles also has to something to do that. So we say that slope is also taken as like we have defined here, like we have defined that slope has something to distance y bar. Same thing has to do with this. So we normally take as tan of theta. Okay, this tan of theta is nothing but is also equal to your slope. And you know how the sin of theta is defined, is normally defined by sine upon cos theta, that is sin theta upon cos theta. So again this height and this height matters. Okay, let's take one more example of these two triangle. Here in this case you see earlier everywhere we have increased the x distances, and we found that height is decreasing, or rather you can say the slope is decreasing. Here we have tried to decrease the x distances, this x distance, okay, whereas we are taking the y. See, this is x, and we are increasing the y. So you see, if you see this example, now the x is less but y is more. In this case your angle here is, okay, your angle is very very high compared to any other angle. So it means that, okay, the angle is increased, so your slope also increased. Slope is highest anywhere here. Okay, further coming to the figures number 7, you see here we again decrease this x distance and kept the y distance. Again if we find this here, the slope is very very high, and this angle also become the bigger, okay, and the slope also become higher. So that is what we say, that is all is the tan of theta is same thing as your change in distance, or distance, y distance and x distance makes your slopes. So this is after understanding this, okay, after understanding this we can go for finding the slopes. So for example, let's say we want to find the slope of a given this. How do we do it? Okay, how we'll do it? So since we know that it is about x and y axis, we say let's draw a simplest triangle, or the slope, I can say best slope, which will refer as a triangle here. Okay, now if I take this a, this is b, and this is c, of course this is a right angle what we're taking. Like that you can find many places, like over the bridge, above the bridge, you'll find such thing happening, and etc etc. This height makes a big difference. Okay, if I define these coordinates here and this coordinates here, when I'm finding this height, that is y coordinates and y distances, for x is not important, let me keep as x only, but what important is the y. Let me take this as y2, whereas here also, since x is not much matter in height, finding the height, what important is y1. Then I try to, if I want to find what is the distance from here to here, and definitely which I'll write as delta y, or simply it will be y2 minus y1. Okay, y2 minus y1. So we'll consider this one point that we know that this distance or y distance can found out by, that is delta is y2 minus y1. Okay, now if I take another example, okay, let's take example, maybe another triangle or same triangle you can take up. Okay, you can label this A, B and C, doesn't matter. Okay, again now since I'm trying to find the x distances, I have more important about is whatever you have can write, not important for me, but since I'm trying to find the x distances here, so it's very important for me, and y can keep as y or y dash something. Okay, so since we know that my x distance important here, so I might write x2 here. This can be something else, x plus y dash whatever. So but here important is x, so I write this as, or this may y dash whatever. So here what is important for is the x distance, so x coordinates are very important. So let me write that is delta x. So it will be nothing but x2 minus x1. Okay, so we have allowed you to 2 points, that is I know how to find my x distance and y distance. So just now we have found out what is slope can be defined, how the slope can be defined, how slope can be understood. So we say slope is nothing but, you can write tan of theta, or you can write in simplest way, that is delta y upon delta x. So in simple words, we know that how you find delta x. Delta y is nothing but it is y2 minus y1 upon x2 minus x1. So this forms a formula for finding the slopes for a straight line graphs. Okay, we'll use this formula to find slopes of different straight lines. Well, let's try to find the graph of we have a graph and we like to find the slope of it. Let's go ahead. Okay, now you see this is the graph we've been already plotted here, as you normally plot a graph with this. Before we finding the slope of the line, what is more important is to understand the equation of the line. Okay, the equation of line is normally given by y is equal to mx plus c, where this m, okay, where this m is nothing but slope of a line. Okay, and where c, this c is the y-intercept. In this case we can see the y-intercept, that is c is a 3 here, and now we need to find the slope of this line. How do we find? Okay, a simplest way of doing it is you know, we have to choose 2 points, any 2 points from this plotted points. Maybe let me choose okay, this point and this point. If you want to label, you can label this A and B, something like this. Okay, now after choosing this point, we need to form like the way we have formed a triangle earlier. So how do we do? So we have this point and this point, the intersection is this. Okay, let's simple way we will join. While making join, make sure that you're joining the way I'm showing here. Just join like this. Sometimes people struggle, they do this and that and this something. No, it's draw up a perpendicular straight perpendicular down towards the x-axis from the point you've chosen per point, and then the lower point can be joined in simple way. Okay, now the next step will be, we need to find the coordinates of these points. Okay, how do we write? If you see this, if you have come to this, you see this x coordinate, so you write this as 2, and this y coordinate you can see directly from here, it is 7. Okay, next is here you can see this point will be, see, x is 2 whereas y is 3. Yeah, whereas this point, okay, whereas this point, okay, you can see here, okay, your x is nothing but 0, but y is 3. Okay, so with this understanding, now we can go for finding the slope. Okay, now you know the word slope should you know very well, that from the equation you can make out you have y is equal to 2x plus 3. If we compare this with this equation, your m is 2, and your y intercept is 3, and from here y intercept is already proved, but you need to prove that slope is also equal to 2. Otherwise also, if unknown, every time you will not get equation, any only points are given, plot a line, find a slope. So here to just make sure that we are doing right, we must get slope is equal to. So let's know, as we just done before some time, we found the formula for the slope. So we can write slope is equal to y2 minus y1, okay, x2 minus x1. Okay, what's y2? As I told you, when I'm going to find a slope, only y and y will be reflecting, we have nothing to do with the x. Otherwise also, if we take 2 minus 2, it will become 0. So when you are doing the y distances, it will be y2 minus y1. So it will be you have y2 is 7 minus 3, and now we want to x distance. In x distance, we important the x distance only. So you see this x and y. Otherwise also, if we take y, 3 minus 2 becomes 0, which has no meaning. So definitely understood is the x distance 2 minus 0. We'll write this 2 minus 0. Okay, so yeah, so we'll get nothing but 7 minus 3 is 4, and 2 minus 0 is 2. Cancel this, you get 2. So the slope of the line comes to 2, which from the equation you are sure that, okay, from the equation given to you, that is y is equal to 2x plus 3, this 2x, the slope is given by 2. Okay, this is how we find a slope. I will try to find one more slope. Well, let's try to find the slope of this given line. No equation is present here. It's just a randomly drawn graph, and you have been asked to find the slope of this given straight line. Likewise, we'll have so many problems in a school to find the slope of you know, particular line which represent something. Because we normally plot a graph with two physical quantities, maybe x and y. Likewise, we can have a voltage and resistance or some sort of that. Accordingly, we know that we are finding some physical quantity through this slope. Okay, so let's try to find the slope of this given line. So I have already marked some points here, means I have chosen some point, or it can be drawn as you normally draw a graph. From this, as I told you, can choose any 2 points when finding slope. These 2 points, these 2 points, or these 2 points, or this first and last, anywhere you can choose. You have freedom to do it. Just for the sake of this, I'll choose okay, this one. Okay, this one and this point, so I'll write is A, and this is right maybe, or this can be a C or something sort of that. Okay, now once I do that, as I told you earlier, we need to drop a straight perpendicular from the here. We need to drop a perpendicular straight from this to this point, from this point to this. Please do not make some sort of doing this and that and that. Just drop a straight perpendicular to the point which you have chosen. Okay, then you have to draw horizontal perpendicular line which intersect this point. See, exactly right. So this is simple way of doing, nothing to worry about it. So finally, to make sure this angle is 90. Sometimes students do this and that, and that's how creates a issue, lots of problem. Okay, so let's see now. As I told you earlier, we need to find coordinates of the given points. If you come down here, okay, let me label for your understanding. Maybe I will take simpler one. 1 2 3 4 5 6 7 8 9 and 10. Similarly, we'll take in the y-axis a similar way. 1 4 5 6 7 8 9, maybe 10. Okay, so your coordinates of this point A will be come down straight. This will be your x-axis, that is a 8. Similarly, see here you get y coordinate, that also becomes 8. Coming to this point, so x coordinate is 8 and y coordinate nothing but it is 4. So write 4 here. Later on again here x coordinate, see, is a 4 and y coordinate should also equal to 4. That's a fantastic. Okay, we have the points now. We only need to find the slope. So how do you find the slope? The simplest formula is given to you earlier. It was slope is given by y2 minus y1 divided by x2 minus x1. Okay, so here is your, as I told you, when taking y you have to consider only y, nothing more than that. You have to consider y and y only, because it doesn't make sense also. Same x coordinate, x coordinate minus 6. So when taking y distance will be y this and y. So y2 minus y1. In this case it is nothing but 8 minus 4, okay, divided by, when taking x distances, that is right, we need to make sure that we're taking x distance. Otherwise also if you take y becomes 0, so it should be this one minus. So 8 minus 4, see, 8 minus 4. Okay, so 8 minus 4 will give 4. This also give a 4. The answer comes to 1. Okay, that is the slope of line. Now in this particular graph, just to make a little bit away to that, okay, this is the graph which have this angle is equal to nothing but 45 degree. Okay, you need not worry about it why so, but just to explain this 45 degree, as I told earlier, the tan of 45 degree is nothing but 1. Okay, just to relate. So also that's why I got slope is equal to 1. So this is how you can find the slope of any given line, any point. It could be in decimals, it could be in minus. If you could have chosen this point also, which says that x is equal to -1 y1 -1. This could also be chosen. But while choosing such point, negative point, you have to give respect to the negative sign. That means negative minus the negative sign whatever you have. So you get final answer. Okay. Hope you understood this. I will continue the same thing in next session. Thank you very much.